However, I have seen the questions you have sent. They were from the paper which has been provided by the academic coordinator.
Yep.
All right, fine. Okay, so it's better to go through the past paper he has recently posted, and after that we can go through them. Just go through the paper, and if you anticipate any problem, then you can ask me, right?
Yep.
Okay, so let's have 18th October, yeah. So now tell me which topics you want to discuss. Yesterday, however, I do want to go through because electron pair sharing reaction or the previous topic, they were really very important, yeah. So
Yep.
we talked about the electrophiles. We talked about the electrophiles. We talked about the nucleophiles. We talked about the photolytic fission. Then we talked about the homolytic fission. We talked about heterolytic fission and thermolytic fission. Yeah, thermofission. Is it clear?
Yep.
All right, let me rub this. So we went through the thermolytic fission. Thermolytic fission. And there is one more thing that is about the leaving group, whether it's an electrophile leaving group, whether it is an electrophile or a nucleophile, right? And then we talked about the reactions. It is already written here, alkene undergo addition reaction. Alkene undergo addition reaction, and all these types are the electrophilic addition reaction, right? On page
Yep.
571, they have made a concept map, and I have already made it not in the same way, but somewhat close to it, right? So this is it that alkene reacts with bromine, aqueous bromine to form halogenoalkane. Then alkene reacts with HX, that is hydrogen halide. Hydrogen
Yep.
halide. Hydrogen halide to form halogenoalkane, and then it reacts with water or steam to form alcohol. However, I'm telling you, I'm not sure about that. But actually, when I teach my student, when an alkene reacts with hydrogen halide, there are two types of reactions which depend on whether the alkene is symmetrical alkene or unsymmetrical alkene. I have
Yep.
checked your book, but there is nothing written related to a symmetrical and unsymmetrical alkene. Now tell me, should I tell you about that? Because this is the point I haven't discussed yet.
Um, if it's not in the syllabus, I think it should be okay.
Okay, all right, fine. Because I'm not very confident about your book. I have seen when
Yeah.
if you remember when I was teaching you alloys or I think polymers, there was something which was there in the questions, but it was not mentioned in the book at all. Yeah, I
Yeah.
don't know. I don't know whether it was about composite alloy or something, because
Yeah.
usually it is not included and it was not given in your book, so I didn't discuss it. But when you were looking through the question, you came across that question, and then you asked me, and I was a bit surprised because I was not expecting that in the alloy thing, right, or alloy chapter.
Yeah.
So that's why I'm a bit. It's better, Minha, that if you do
Yeah.
it,
Yeah.
because you know what, I'm not confident when I compare this with our board. Whatever is given in the book, only that thing is included, right? So we are very
Yeah.
sure that what we are teaching to our students is all related. But in your
Yeah.
book, I have seen that there are so many things where, if you remember, I have discussed so many things with you, which I told you that although they are not in your book, but I'm discussing because I think they are important. But when we did
Yeah.
the exercise question, then we came to know that the content was there, but it was not discussed in the book. So I am going to discuss that, right?
Yep. Sorry, could you just give me just 1 minute?
Sure.
Yep, sorry.
It's okay, no problem. It's all right. So, what do you suggest? Should I tell you about that?
Yep, sure.
All right, fine. So first of all, I would tell you that is about the symmetrical and unsymmetrical alkene. Although it is related to what it is related to alkenes, yeah. So it's
Yep,
about symmetrical and unsymmetrical alkene. So I'm taking this. First, I'm dividing alkene. All these points are, by the way, all these points are clear. Anything you
yep,
want to discuss about fission or thermolytic or homolytic or hetero, photo? All is fine?
yep,
All right, fine. So alkenes are of two types. Number one, symmetrical alkene, and the other one is unsymmetrical alkene. Now, as indicated by the name symmetrical alkene, what is the meaning of symmetrical alkene? Let me make this CH2. Now, this, which is ethene, this is an example of symmetrical alkene. Now, what is the meaning of symmetrical alkene? Symmetrical alkene means that around the double bond, the number of hydrogen atoms towards both the sides should be the same along with the carbon. So
yep,
if we check a double bond around double bond or towards both the sides of the double bond, there is one carbon, and each carbon has two hydrogens each. All right. So
yeah.
this is called a symmetrical alkene. So when a symmetrical alkene undergoes addition reaction, any addition reaction, let's suppose I pick HBr or HX, right? So when it undergoes addition reaction, so it's like this, CH2, which is ethene, which is an example of symmetrical alkene. And when it reacts with this, which is actually an unsymmetrical molecule, HBr, you know that I'm not writing down the mechanism, direct reaction. Hydrogen would be added anywhere, either on carbon 1, I will label it carbon 1 or carbon 2, and bromine would be added to the other carbon, right? Saturating the bond, and it becomes the existing molecule is this, and the added atoms are here. All right. So what does it become? It becomes one bromoethane. All right. If you
Yep,
have noticed that I have um, randomly added hydrogen to this side and bromine to this side. If you do the other way around, that is hydrogen to this side and bromine to this side, it won't make any difference. Do that. So it would be
it would still be one bromoethane.
yes, it will still be. Now I am adding bromine to the, I have shown it with a purple color, yeah? So now
Yeah,
bromine would be here and hydrogen here would be here. Still, it will not make any difference. I'll start the numbering from this side, and this is one bromoethane. So no difference at all. However, if is it clear, Minha?
yep,
So, however, if I take propene, the very next member, this is ethene, and now I'm taking propene. So, when I take propene, one, two, three, and let me now counterbalance it. So, here it is. So it becomes CH3, CH3, CH, and CH2. If you check the valency of carbon for each atom, one, two, three, four, correct. Now come to the second carbon, one, two, three, four, correct. Now come to the third carbon, one, two, three, four, correct. Is it clear? But
yep,
now, if you look at the double bond, this is the double bond. Around the double bond, this carbon has two hydrogens, and there
yep,
are two carbons towards the other side, and this carbon has one hydrogen. So I'm going to compare it in two ways, first in terms of carbon and then in terms of hydrogen. However, let me tell you that hydrogen is going to take the preference. That for the very first thing we need to check is the number of hydrogen around it, right? So this is the
yep,
double bond, this is the carbon, and this carbon is linked to two hydrogens. However, this carbon towards the other side is linked to only one hydrogen. So when this is
yep,
the case, this is called as unsymmetrical alkene.
yep,
Good. Now, when I am going to add hydrogen halide, that is HX, to an unsymmetrical alkene, I have to follow a rule, or a, yeah, and that rule is called as Markovnikov's rule. Markovnikov's rule. All right. Now, what is this rule? Okay. This rule says that when, and I am going to write it, when an unsymmetrical molecule adds to an, I will write it, then I will explain. Okay, beta?
Yep.
Adds to an unsymmetrical alkene, the more electronegative part of the molecule adds to that carbon of the double bond which is linked to lesser number of hydrogen atom. This is the rule. Now, if it's not given in your syllabus, you do not need to memorize it. However, you should know what to do. So let me repeat it. When an unsymmetrical molecule adds to an unsymmetrical alkene, what is the unsymmetrical molecule? HX. Why it is called, or HBr, or HCl, or HI, or HF, right? Now, why it is unsymmetrical? Because towards one side we have hydrogen and towards the other side we have bromine. So it is not the same. So that is why it is called as unsymmetrical molecule. Got it?
Yep.
When an unsymmetrical molecule adds to an unsymmetrical alkene, I have already told you what's an unsymmetrical alkene, that if we talk about the double bond, the carbon atoms towards both the sides of the double bond, they should have equal number of hydrogen. However, this carbon has two hydrogen and this carbon has only one hydrogen. So it means it's an unsymmetrical alkene. The more electronegative part of the molecule. Now, which is the electronegative part of the molecule? If I take HCl, so because chlorine is more electronegative, so it is going to get a partial negative charge, giving a partial positive charge to the carbon atom. So what is the more electronegative atom? Cl is the more electronegative atom. So the more electronegative atom, the more electronegative part of the molecule adds to that carbon of the double bond which is linked to the lesser number of hydrogen. So it means that this Cl will go to this carbon because it is linked to lesser number of hydrogen. It will not go to this carbon which is having more number of hydrogen atom. Does it make
Yep.
sense? Yeah. All right, good. So now if I will write the product would be that I'm going to add this here and eventually this will come here. So the product I'm going to get would be C, C, single bond C. Now the existing hydrogens would be like this, and the new atoms would be here Cl and here H. So we are going to get 2-chloropropane. We are not going to get 1-chloropropane. It is a major product and the minor product would be the wrong way. But don't say that it will not form. It will form, but in a very, let's suppose 90% would be uh, 2-chloropropane and 1% would be, let me write better, 1% would be 1, 2, 3, and hydrogens here, 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 and now 1% would be H and Cl, that is, this one is 1-chloropropane. So 10% would be 1-chloropropane and 90% would be 2-chloropropane. In other words, 2-chloropropane is called as the major product and 1-chloropropane is called as the minor product. Now take your time
Yeah.
in understanding it, and if something is not clear, you may ask.
Yep. Okay.
Okay, well done. So this is about the look. It takes only 10 minutes to explain it, but now I am satisfied that you know it. That if it comes in the paper, at least you should know what to do with it. All right.
Yeah.
So this is called as Markovnikov principle. Okay. Now,
Yeah.
as far as fission is concerned, now anything else you want to ask, Minha?
No.
All right. So as far as fission is concerned, you need to know about the arrows. Let me tell you, there is a single arrow, there is a double-headed arrow, there is a curly arrow like this, there is a curly arrow like this. So if this is for the normal equation, this is for the reversible reaction. This is when you want to break a bond due to polarity. I'll give you example. To break a bond due to polarity. And this is something which is meant only for homolytic fission in the presence of UV. Now this is normal equation like C plus O2, that is CO2. All right. And this is for reversible reaction, that is N2 plus 3H2 to NH3. This shows that it's a reversible reaction. For this, the third one, break a bond, to break a bond due to polarity. So if we have HCl, and it is because it is electronegative, so partial negative and partial positive. And if I do like this, if I do like this is called as a curly arrow to show the breaking of the bond. This is not for the breaking of the bond. And homolytic fission would be Cl and Cl. And then I am going to show it with the half-headed arrow. And this is called as UV2Cl dot. That means radical formation. Is it clear?
Yep.
All right, good. Now the other thing is in your book, yeah, I am telling you this because it shows the it has been shown in your book, right? However, this one has another meaning, that is, let's suppose if I am going to show like A plus and it reacts with nucleophile. A plus means carbocation. All right,
Yep.
carbocation. And if you react with the nucleophile, then you need to show the arrow. Most of the time, nucleophile, if it's water, it would be without a charge. But if it is cyanidine, it will definitely have a charge. So what do? You never extend the arrow from the from the negative charge. You will extend it to the from the lone pair to the other atom, and this shows the sorry. This is again the curly arrow, and this shows the movement of the electron pair from nucleophile to the electrophilic carbon atom. So there are two meanings of the curly arrow. One is the breaking of bond, which I have shown, and the other one is what? It is the movement of the lone pair from from the nucleophile to the electrophile. Is it all clear?
Yeah.
All right. So anything else? One thing more. Again, it is not mentioned in your book. I I don't know whether I should teach you this thing. It's about positive inductive effect and negative inductive effect. Have I told you about this before? I think I have.
I'm not too sure.
Not too sure. All right. Okay. Now, anyway, to one thing more. When we talk about homolytic fission, homolytic and heterolytic. I'm discussing those points which I think I should have discussed in detail. So I'm just trying to cover them by giving the examples. Now, if we talk about homolytic fission is going to produce, which is this, I have already shown you with a half-headed arrow, it is going to produce the radicals. However, the heterolytic fission, which is which is depicted by a full-headed arrow, it is going to produce two oppositely charged ions after breaking. Charged ions like H positive and Cl negative. All right. And
Yeah.
then the other thing, homolytic fission involves UV light, and heterolytic fissions does not involve UV light. It can take place as sometimes, most of the time rather, at room temperature. All right.
Yep.
And then anything else? Yeah, then comes the, I think there is no need to discuss the saturated and unsaturated compound. Then we have the discussion of electrophile and nucleophile. So I think I have told you, but still, electrophiles are the species which are electron deficient.
Yep.
Electron deficient. And nucleophiles are the species which are electron rich species. These are electron deficient species. It is electron rich species. What is another point about electrophile and nucleophile? That electrophile, yes, any point which comes to your mind?
Um,
It is electron pair acceptor, yeah,
yep.
and it is electron pair donor. Sometimes they ask you to differentiate between electrophile and nucleophile. Electron pair donor.
Yep.
Sometimes it has, most of the time rather, it has a partial positive or full positive charge.
Yep.
All right. And it has a negative charge. The examples are, right? Yeah, all right. Now, electrophile attacks on the electron rich carbon atom, or electrophile attacks on the pi bond. It's better. Attacks on the pi bond. That is the double bond. And nucleophile attacks on the electrophilic carbon atom. All right. The examples are nitronium ion. All right. No, one thing is left. Electrophile can be like AlCl. This is a very good example. It is not given in your syllabus, but I am explaining it because I think it's good and important, right? So
Yep.
when we talk about electrophile could be what? Like AlCl3. This could be an electrophile, right? So what do you think? Why did I write this? Any idea?
Because
Electrophile. Hmm?
it'll accept the electron pair.
Electrophile is AlCl3. If I talk about AlCl3, let me draw this. This is AlCl3. Now this is AlCl3. So one, two, three, and then chlorine, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7. Now it's there right in front of you. Now can you make a guess? A correct guess? Yes. That I'm telling you it's an electrophile. I'm telling you. I'm simply, but I'm asking why it is an electrophile. What makes it an electrophile? Yes.
Um,
Any idea? Yes. Any
um,
guesses?
it has like um,
Hmm?
not sure.
Okay. This space. Oh dear. This space. Empty space.
Okay.
Empty space. So it can actually, what is an electrophile? Electron deficient species. All
Yep.
right. So that means, look, now check how many electron pairs are there around the central atom, which is aluminium. Two, four,
Two.
six. And you know that octet can be completed.
Yep.
All right. So if this, now have a look, if this reacts with chloride ion, now be very careful. Now what is going to happen? that chloride ion would give its electron pair here.
Yeah.
Okay, now let me draw it in this way, then it will be very clear to you. Let me draw the chloride ion like this. Cl negative. So that would be, it is an ion. So that would be, I'm going to make it with purple. One, two, oh dear. One, two, three, four, five, six, seven, and this is the gained electron. All right.
Yeah.
So one, two, three, four, five, six, seven, and this is the gained electron. Now, if are you getting it, Minha?
Yep.
Now, if beta, I will bring it here and here. Now, have a look. Now, chloride ion has given its lone pair to aluminium. Yeah,
Yeah.
just a minute. Chloride ion has given its lone pair to aluminium and it's a dative bond. So now
Yep.
we have Al, Cl, 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 and the head of the arrow should be towards aluminium because it is accepting the electron and this is negative. So this is called as AlCl4 negative. Are you getting my point?
Yep.
So I have shown you with the dot and cross diagram. However, it most of the time in the books, in your book, it is not given, but in most of the books, it is given like this. Cl negative, then this one, and then they show the attack on this, and then they make AlCl4. All right. So then they write this and this whole is negative one charge. So this
Yeah.
AlCl3 is also an example of an electrophile.
Yeah.
So
Okay.
this got my point.
Yep.
Good. And apart from this, there are other examples of electrophile. I have already discussed them. That is nitroniumine or carbocation like this. It could be tertiary carbocation. It could be, have a look here, secondary carbocation, or it could be primary carbocation. Now I have, this is the example of tertiary carbocation, secondary carbocation, and primary carbocation, right?
Yep.
And then the other electrophile, because yesterday I discussed it in a hurry, so I wanted to discuss it in detail. Now the other
Yep.
example, so this is bit of first example, this is the second example of electrophile. These are the third examples of electrophile. Now there is another example of electrophile, which is because it's in your syllabus. Aldehydes and ketones are in your syllabus, yeah?
Yep.
So, yeah, so I am making an aldehyde and I am making a ketone. So here it is. You know that, let me, for aldehyde, this would be CH3 and H. For ketone, it would be CH3 and CH3. Now, please don't get confused. It could have been made like this, Minha. CH3, CH3. It's not wrong. It's correct. But technically, the bond is not between hydrogen and carbon, it's between carbon and carbon. So it's better to show the bond with the carbon. It makes you technically correct. Otherwise, if you are going to make like this, it would be fine. Are you getting my point?
Yep.
Good. So now you know that it's an aldehyde. This is an aldehyde and this is a ketone, right? So if we talk about the structure, you know that oxygen is electronegative in nature. So it is going to attract the shear pair of electron towards itself, getting a partial negative charge, giving a partial positive charge to the carbon atom. Same goes here with the ketone, that oxygen is electronegative in nature. So getting a negative charge and giving a partial positive charge because the shared pair of electron of chlorine as well will be attracted by the oxygen atom. So when this comes, this is a very good electrophile, but it is the part of the molecule. All right. So that is
Yeah.
why I'm going to give you the example. That is, what is this? This is ethanol. And what is this? This is propanone. By the way, aldehyde starts with an ethanol, methanol, sorry. Aldehyde starts with methanol and ketone starts with propanone. This is a very important point. Are you getting what
Yep.
I'm saying? So this is also an example of an electrophile. But keep this thing in mind, it's a part of a molecule. It's not
Yeah.
separate. However, this is separate. Look, this is separate.
Yeah.
Is it clear? So, beta, I have for electrophiles, I have given you four example. All right. Now there is another. I have written one, two. Yeah, with nitroniamine, you can add beta Br positive or H positive. Br positive comes in alkene. When bromine, aqueous bromine sees alkene, you know that alkene decolorizes the bromine water, which is of orangish red color.
Yeah.
So that means that there is a reaction which takes place between alkene and the bromine water. So
Yeah.
when alkene approaches bromine, aqueous bromine, which is like this, you know that bromine is non-polar. You know that, yeah? So
Yeah.
instead of writing Br2 like this, I have written it aqueous, sorry. But like this, I have written it like this. Now, bromine knows that if I am going to stay non-polar, then alkene will not give me the electron. So what does it do? It makes this side partial positive, especially this side, and this side partial negative. Now alkene will say, oh, it is deficient of electron. Rather, in writing in this way, it's better to write in this way because it makes the things clearer.
Yeah.
Like this. H and H and H and H. Now, when it's very what I can say strange that bromine, which is non-polar, but when you react it with alkene, it shows alkene as if it is deficient of electron. Yeah. So what alkene does? It gives its electron to this, and the bond gets broken between bromine and bromine. Is it clear?
Yeah.
So what is this actually, Bridget? This is the electrophile I am talking about.
Yeah.
Good, great. So that was it. I think I have, yeah, in your book, they have mentioned, if you check page number mm, 574. So they have made the curly arrows, yeah? I have already told
Yeah.
you about these arrows.
Yeah.
Clear? All right, good.
Yes.
And then homolytic fission and hydrolytic fission. Yeah, this is something important. I need to tell you this thing. Have I made the difference between heterolytic and homolytic somewhere? No. Bitter, today's lecture is very important. Number one, I told you the difference between symmetrical and unsymmetrical alkene, right? Then I told you about the Markovnikov's rule. Then I told you about the types of the bond arrows. Then I told you about the difference between electrophile and nucleophile. And then I gave you a new example as well, right? So I have not I haven't left any stone unturned. I tried my level best to explain all the things, whether they are in your book or not. Now, the last thing, now, the fifth thing. Is it clear, Minha?
Yeah.
Any question better till now?
No.
Good. Now, one more thing about homolytic and heterolytic fission. Homolytic fission, it is very important. Heterolytic fission. The very first thing, let me start off with the example that is H, sorry, Cl and Cl. And hydrolytic fission is HCl. All right. So again, number one, it's a covalent bond. It's a covalent bond, and it is also a covalent bond. All right. But if I am going to break, fission means breaking.
Yeah.
Fission means breaking. So I am going to break the bond. In case of homolytic fission, this is the first point. The second point is in the homolytic fission, UV rays are required, while in this, no UV rays.
Yeah.
Now, the third point is when homolytic fission is represented by half-headed arrows, while heterolytic fission is represented by a full-headed arrow. Not arrows, arrow. This is
Yeah.
important. Here it is, arrow and arrows. Now let me show it. CLCL, that would be two half-headed arrows. And this one, HCl, now there would be partial negative, partial positive, a full-headed arrow. Now the fourth thing is, after the fission, two radicals are formed. In this fourth, two two ions are formed. This is the very important difference. That means, now let me complete this equation. Cl, half-headed arrow, UV light 2Cl dot. While in this case, HCl, now when the breaking takes place, both the electrons will be now partial negative, partial positive, arrow is, oh sorry, bond is broken, and between now I am going to get H positive plus Cl negative. What does it mean? It means that the shared pair of electron, if I will draw the diagram, that would be H and Cl. So that would be HCl 1, 2, 3, 4, 5, 6, 7, and hydrogen is going to bring its electron here. So both these electrons, when this bond breaks, both these electrons will be taken up by chloride ion. So it becomes like this. It becomes like this H positive and Cl negative. Oh dear. Cl 1, 2, 3, 4, 5, 6, 7, and this is 8, and this is Cl negative plus Cl negative. Is it clear?
Yep.
All right. So these are the unpaired electrons. These are the unpaired electrons. All right. So in your book, they have mentioned it like this, that ClCl. No, they have mentioned it like this, ClCl, and then Cl dot plus Cl dot, and then they have written HCl, and then a H positive and Cl negative. I hope it's clear, right? And then the last difference is between Minha, what we have done today. Please do take a screenshot or get the printouts, or you can write it in your writing, but do have it close to your study desk so that you can repeat it again and again, right?
Yep.
And then the last one is difference. Now, sixth thing. Now, sixth thing would be difference between um, radical and ion, atom, sorry, radical and atom. So this is a radical. Radical is something which is formed after UV, after UV light, or using UV light, not after using UV light. Using UV light. So this is Cl and Cl. So this would be the radical. An atom is something which is present in the periodic table, and it is not high energy particle. Not high energy particle. However, radical is a very high energy particle, and it has the ability to change a molecule into a radical by
Yep.
bombarding on it. And atom doesn't start it does not, now this is 1, 2, 3, it does not start a chain reaction. Atom, I'm talking about atom. It doesn't start a chain reaction. And radical, it starts a chain reaction, and then you have to terminate it, otherwise it will never finish. You
Yep.
have to terminate it. For example, you must have seen some science fiction movies, yeah? So in that, you have to terminate that thing until, and otherwise it will destroy everything, right? The
Yep.
effect is devastated. So that is why you need to terminate things. So you have to terminate it. That's it. I think I have covered everything, Bete. That's it from my side. Now you tell me, what do you want to discuss?
Like in regards to this topic?
Or yeah, yes, because we did these 74 chapters in a great hurry. So if you think that something is still nagging you, we can discuss it. I can even tell you this thing, Minha, that that aldehydes are more reactive than ketone. I can tell you this thing, or I can tell you about positive and negative inductive effect. This is the only thing I have left. Otherwise, I have covered everything. Now you tell me.
Yeah, could you tell me about that?
Yes, I think it's better. It's better because I am not confident about your book, so it's better to know about the inductive effect, right?
Yeah,
So this would be the last point. After that, Alhamdulillah, I am sure that I have taught you each and everything, which ever chapter I have taught you in detail. So I think,
yeah,
inshallah, no question would come from those chapters which we have covered together that is not known to you, right? So, all right.
yeah.
Inductive effect. Now, there are better two types of inductive effect. Number one is positive inductive effect, which is called as plus I, positive inductive effect. Positive I and negative inductive effect. By the way, Minha, I was thinking how many chapters or how many parts you have covered with me from your book.
Um, almost the whole thing except for structure one and reactivity one.
Okay. Yeah, I was thinking that there was something left. Anyway, just wanted to be sure about the syllabus, that what has been covered. I
Yeah,
think we haven't discussed the reversible reaction, or have we?
like equilibrium and stuff.
Yes, yes, yes.
We discussed it like a while ago.
Okay, okay, okay. So positive inductive effect and negative inductive effect. All right. They are represented by negative plus I and negative I. Now, what is plus I and negative I? Positive inductive effect means, now in very simple language, positive inductive effect means supporting a species, and negative inductive effect means imbalancing or disbalancing a species. All right. Now let me, positive inductive effect is given by R group. That is that is CH3, all R groups, methyl, ethyl, propyl, butyl, pentyl, and so on. And negative inductive effect is given by mostly X group, that is group 7. All right, that is
Yeah,
chloride, chlorine, bromine, iodine, and fluorine. They give negative inductive effect. Now, what I'm going to write is really very, very important, that negative inductive effect makes a good acid.
negative or positive?
Negative, negative. Oh, I have written it in under positive. Sorry.
Yeah,
All right. So, a negative inductive effect, if attached to an acid, makes it a good acid. R group, I'm talking about this, right? If attached to an acid, makes it a weaker acid. This is very important.
yeah.
Now, the next point is, this is maybe I will not be able to write in negative inductive effect, but it will help you in understanding. However, let me write positive. This is not that point. Positive inductive effect groups um, causes cause steric hindrance. Now, negative inductive effect groups do not cause it. Cause what? Cause it means steric hindrance. Now, the last point, which may not be, this is the point I was talking about. That is positive inductive effect. That means R groups decreases solubility. Now, let me, is it clear? If you want to read them,
Yeah.
you can. All right. Now, okay, I'll take a 30-second break. Okay.
Yeah, yeah.
All right. Okay. Now I was waiting for you to read it out. Anyway, all right. So when we talk about the positive inductive effect, if you remember, these are the R groups.
Yeah.
All right. Oh, one thing more. Uh, I'm also going to take a picture of this. I will share with my class. All right. R group makes the carbon atom less electropositive. Less electropositive. That means make it a weaker electrophilic center, electrophilic center on which nucleophile will not readily attack. Let me underline. Weaker electrophile, nucleophile will not readily attack. However, X groups makes the carbon atom more electrophilic, comma, that means, I hope my writing is not very bad. You can easily read it, yeah?
Yeah, yeah.
All right. That means make it a stronger electrophilic center on which nucleophile readily attacks. That's a very important uh, difference, and this answers lots of queries, right? So I have told you how many points: one, two, three, four, and five. And six. Oh, good. All right. Now, if you check this bit, these are the R groups. Can you see that? These are
Yeah.
the R groups. Now, if they are the R groups, that means they are going to cause positive inductive effect. All right.
Yeah.
Now, this oxygen is going to cause negative inductive effect. I hope you are getting it, right?
Yeah.
Now, if it is electronegative in nature, it is going to make this oxygen electronegative, and it is going to attract the shared pair of electron towards itself and making this carbon electropositive. When it becomes electropositive, this means an electrophilic center. All right.
Yeah.
The better it is electropositive, the better the positive charge comes on it, the better it would be the electrophile. It would be a better electrophile. So this group makes it a better electrophile. Now, what happens? Carbon starts whining that I don't have, my electron density has been taken by oxygen. My electron density has been taken by oxygen. Then these R groups will say, don't you worry, we are going to incline our electron density towards you just to support you. Are you getting my point?
Yeah.
So when they will support this carbon, so carbon would have less positive charge, and when this would have less positive charge, a nucleophile will not attack readily on this carbon atom. Is it clear?
Yeah.
And now aldehyde. In case of aldehyde, in case of ketone, there are two R groups, while in case of aldehyde, there is only one R group. So again, oxygen is going to attract the shared pair of electron towards itself, giving it a partial negative charge, giving a partial positive charge. Now again, carbon will start crying that my electron density has been taken away by oxygen. So again, this only, now there is only one R group. there is only one R group to support. So our group will say, okay, I am going to shift just to incline my, I'm not going to give you my electron. I'm going to shift my electron density towards you. And if let me make methyl so you will understand why I'm saying so. H. Now have a look. One methyl group has how many atoms? Sorry, electrons. Now look. Can you see six electrons? One, two,
Yep.
three, four, five. All these six electrons will be, instead of being here, they all will come to this side. They will be more
Yep.
towards this side and they will try to support carbon. But there is only one methyl group to support, unlike ketone, which has two methyl groups. So still, this carbon will have less support. It will not be greatly supported by the R group. So the electrophilic center would remain there. It would be a good electrophilic center. And that is why nucleophile will readily attack on it. That is why aldehydes are more reactive than ketones.
Yep. Okay.
Got it?
Yep.
Good. And now the last point from my side is, where is the carbocations I was talking about? Just a minute. Let me, if you see somewhere, do tell me carbocations. Here it is, carbocations. Now in these carbocations, now have a look. Now which is the most reactive carbocation and which is the least reactive carbocation? Can you tell me that?
Primary is the more reactive one.
Which one?
Primary.
Yes, well done. So primary, I am using two words, beta. Primary is more reactive and less stable.
Yep.
Tertiary is less reactive and more stable. Why? Because when this carbon will start crying, because it is having a proper positive charge, it's not a partial positive charge, it's a proper positive charge, that one valency is less. When carbon starts crying, look, I'm not deficient of electron, my electrons have already been taken away. I don't have complete electrons. So all these three R groups. Now you know about one R group. One R group shares shifts how many electrons? Six electrons, right? So
Yep.
six, six, six. That means 18 electrons. So these R groups will say, "Don't you worry. We are going to incline our electron density towards you so that you will get some support." So that is why when carbon is going to get the support from three sides, that is tertiary, it will not react fast because it has some sort of support. While in case of primary, there is only one R group to support or to give its or to share its electron density. Hydrogen is very innocent. It is not going to support because it has only one electron. So it will not be satisfied. It will keep on crying, and so nucleophile will readily attack on it. That is why it is reactive.
Yep.
That's it. That's it from my side. I now I am satisfied that you know about the inductive effect as well. However, negative inductive effect, one point which is not discussed right now is the acidity, right? Now have a look,
Yep.
bache. Now if I have, let's suppose I have CH3, C double bond O, OH. This one, it's an acid, right? You know that
Yep.
it's a weak acid, right? Now, actually, when this hydrogen is donated as a proton, then it becomes a good acid.
Yep.
All right. Now, this is one example. By the way, let me write the other example. Let me change it to this thing. Just a minute. C, H, H, and H. Now I will write Cl, 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 C double bond O, OH. Now have a look. Now this, when this hydrogen will be given out as hydrogen as a proton, then it will be an acid. Now, let me put the charges here, partial negative and partial positive. This is electronegative in nature, and this is going to attract the shared pair of electron towards itself. And then what is going to happen? This hydrogen can be given out easily as a proton and it will be an acid, right? But
Yep.
weak acid. Why? Because this oxygen is electronegative in nature. So it is going to attract the shared pair of electron towards itself. Not only the shared pair of these two electrons, but this shared pair is also being taken up by oxygen. So what happens that this carbon becomes electrophilic from both the sides. Can you see it is electrophilic from this side as well as from this side? So
Yep.
this becomes double partial positive. All right. But and this oxygen which is doubly bonded, let me rub this all. This oxygen which is doubly bonded, it's so reactive. Doubly bonded oxygen is more reactive that it will not attract the shared pair of electron towards itself of these bond, but also of this bond and this bond, right? So what happens
Yep.
actually that this carbon becomes partial positive, but this partial positive thingy will be weakened by this R group. This R
Yep.
group says, okay, I'm going to shift my electron density to you so that you can get some support. When this becomes less electropositive, this bond also becomes less electronegative. And this hydrogen is not given away easily, so that is why it's a weak acid. Are you
Yep.
getting my point? Now come to this one. The same, the rest of all the things would be the same. The only difference which you can see beta is these three chlorine atoms. Instead of methyl group, now we have the chlorine atoms. Yeah. And you know that chlorine atoms are electronegative in nature. All right. So
Yep.
they are not going to give any support to this carbon atom.
Yep.
Rather, they are going to take the support away. So what is going to happen when now rubbing it, now what is going to happen, bache, that the electrons would be, these chlorine would attract the electron of towards this side of this carbon, this oxygen and this oxygen as well, right? So what is going to
Yep.
happen when all of these would be attracted by chlorine? This would be given out very easily. That is why it's a strong acid.
Oh, okay.
This is a strong acid. I hope it's clear. Now, the
Yep.
only difference, bache, this is same, this is same, this is same, this is same. O is same, O is same. The only difference is of R group. Now, check
Yep.
that if R group is taken away, then thing becomes stronger. I hope it's clear. However,
Yep.
last point, let's suppose if you replace only one hydrogen, that means it remains H and H. It would be a weak acid. As soon
Yep.
as you replace one more hydrogen by Cl, it would become more acidic. If you replace the last hydrogen by Cl, it would be the best acid. I hope it's clear.
Yep.
That's about it. That's about it. I think I have explained everything as far as solubility is concerned, bache. And steric hindrance. Steric hindrance, bache, can you see this methyl group where it is? CH3, big C. Here it is. Now, even just think that if there is another CH3 group here, if there is
Yep.
another CH3 group here, then there is no space through which electrophile can attack. So
Yep.
what does it need? It needs to make electrophilic carbon atom. Now it has to make this nucleophile needs to make a space by taking away all the electron so that some space would be made to attack. Are you getting my point?
Yep.
These now look, three methyl groups. Have a look. This, and this. Can you see any space from where nucleophile can attack? No. So that
No.
is why it has to break this bond. So space would be made so that nucleophile can attack.
Yep.
All right. And the last point is about the solubility, but take greater the, always keep this thing in mind. I will add somewhere. Where is it? R group decreases solubility. That means R group, they are hydrophobic in nature.
Yep.
They are hydrophobic in nature. That means water hating. Phobia, water hating, right? So in this way you can learn it. Phobia means you hate something, right? So
Yep.
hydrophobic means hate of water, hating water, right?
Mm,
So greater the carbon chain, bache, this is a smaller carbon chain, and this one is even bigger or longer, and this one is even longer. So greater the carbon chain, lesser would be the solubility. And carbon chain means somewhat, carbon chain means R group. So which
Yep.
R group is this, beta? This is 2. This is C2H5. This is C3H7. This is C4H9. So this is ethyl. What is this? Ethyl. Ethyl R group. This is propyl. This is butyl. So all these are the R groups. So
Yep.
greater the R group, lesser would be the solubility. Is it clear,
Yep.
Minha?
Yep.
All right. Alhamdulillah, I have tried my level best to cover organic chemistry in all possible way. By the way, today's lecture is really very important because I have made the differences. Okay?
Yep.
All right. So we started, I think, our lecture from here today. No, uh, uh, from
Yep.
here. Yes.
Yep.
Yeah. Right. So today is what, 27th?
Yep.
27. So I,
26.
oh, 26. Okay. So I have, Alhamdulillah, I have completed everything. Any question, Minha?
Nope.
Sure.
Yep.
Okay. So, all right. Now what are the plans? Pops papers?
So,
Mm.
I wanted to just go over enthalpy just once.
Once. Which chapter is this? Let me check. Can you tell me the page number?
Mm, Bond enthalpy 328.
Let me check it. 328.
Just wanted to go through it like quickly, like just so I have an overall idea.
Just a minute. Let me check. Okay. In the next class,
Yep.
328. 3 328.
We
Okay.
don't have to follow the book, but I just wanted to like know about bond enthalpy.
Okay. Okay. Let me have a look at the chapter and then I will let you know. Oh, it's about Hess's law.
Yeah,
Oh, yeah. Students, they find a lot of difficulty in this.
I understand Hess's law, but I just have to practice a bit of questions. But I'm a little bit unsure in enthalpy.
Okay, fine. Fine. Okay, then I will cover it in tomorrow's lecture. The whole chapter, yeah?
Uh, yeah.
Or or
Or we
anything else. Yeah?
can we do bond enthalpy and the questions for bond enthalpy?
Sure. From the past
Because there's
papers.
yeah, because there's a lot of calculation questions that come in the past papers,
Okay, fine. So which questions do you want to do? The questions given in the exercise or from questions from the past papers? You tell me.
past papers.
Okay, fine. Fine. So I'm going to make a worksheet
Yep.
and we will do that worksheet. I'll try to post that worksheet today till
Yep.
night and you can do it by tomorrow. And when we will discuss the class, then you can tell me about your problems.
All good.
Okay, fine.
And
Okay.
then the mock, is it like
I have made it almost, it's almost complete. I'm
all
going to
good?
upload it today or tomorrow. By the way, I have made the paper of MCQs.
Yeah, yep, no worries.
All right, fine, fine. From the whole syllabus.
Yep.
Good, good. Okay. All right, Minha. Thank you so
Thank you so
much.
much. Thank you.
Welcome. Take care,
Normal
better.
time
Yeah.
tomorrow?
Normal time, yes. Today was
All
actually
good.
my holiday, so that's why I gave you earlier time, right?
Yep, yep. And then I was hoping to have a class like every day until Sunday.
Next on Sunday. Okay.
Until Sunday.
That you are going to have a class every day, right?
Yep.
So maybe for 2 days I need to check and I'll
Yeah,
let you
yeah.
know, right? So,
No
okay,
worries.
fine. And what is the plan for the whole week?
So tomorrow will be the enthalpy and then the questions,
Yes.
and then a lot of calculation type questions from past papers.
Okay. So any topic, specific topic?
Um, there's usually like I can send you like questions, like the type
Yeah.
of questions that I'm talking about.
All right, fine. By the way, Minha, it's better to do a lot of practice. Yeah. So do send me the question. I am going to take out the or topic. You can send me the topic or the question, and I am going to take out the question related to that or similar to that question, and then we can solve it. And it's better if you chalk out a plan for that, that what you are going to
Yeah,
do each and every day. Yeah.
yeah, yeah,
Okay, so do make a plan and please do share it on the WhatsApp group so I'll have an idea that what type of questions because now from now onwards we will have the practice questions. Okay.
yeah.
Okay. So I'm not going to take any question from the book, right? So all the questions which I will give you would be from the past papers.
Yep.
Good. By the way, when I will teach you Hess law, I'll tell you a trick as well.
Yep. Okay, all good.
Right? Okay. Okay, Betty.
Thank you so much.
Welcome. Take care. Allah
You too.
Hafiz.
Allah Hafiz.